In this video, I'm going to go through a multiple choice question on resonance structures and explain the correct answer and also explain why the distractors given are not correct. So the first thing I'm going to do, rather than look at the distractors, I'm actually going to draw out the resonance structures for this molecule. So I'm going to delocalize the electrons that are on the nitrogen across that single and then double bond, and I'm just going to draw out the correct structure that I would get as a result of that. So I've got my methyl group CH3. I'm just going to draw in first the single bonds and then work out where I have double bonds and where the electrons are positioned. So I'll have a double bond now between the nitrogen and the carbon. I'll have a positive charge on the nitrogen. And on the oxygen, I already have two lone pairs. I've then added two electrons from the movement of electrons onto the oxygen. There's now a negative charge on the oxygen. So this is the correct resonance structure that I would expect from this molecule. Now, if I have a look, and let's go through each of the structures. So obviously looking at A, B, C, and D, B is the correct answer because I do have my positive charge on the nitrogen, negative charge on the oxygen. The molecule is neutral, the resonance structure is also neutral, and I've got three lone pairs of electrons on the oxygen, so B is correct. But let me just go through the other options. So for A, there's a double bond between the two carbons, which you cannot obtain from the resonance structures because you've got the lone pair of electrons here, and then you have a single bond and a double bond. There is no way that the electrons would just have moved, or that double bond between carbon and oxygen would move there. So that's completely incorrect. In structure C, there's a positive charge on nitrogen, but you cannot have a double bond to hydrogen, so that is incorrect. And in structure D, there's a negative charge here on the carbon, but there's no positive charge to balance that out. So that's the obvious thing to check. The charges are not balanced. And then there's a lone pair of electrons on carbon, but actually how that would have happened from this starting molecule does not make sense. So D is also incorrect. So I hope that you can at least follow that question and understand how you get to the right answer.